Students, welcome to your CC341 microprocessors tutorial class. This is a continuation of the first video on microprocessors. In this video, we will learn about microcontrollers. Now students, we know that we need a processor where there is the need for executing programs, right? For example, in a computer, we need a processor for executing all the different programs and all the different instructions. But in a computer, this execution of programs is very intense because a computer has to perform so many different tasks. What if I have a machine where I have to execute programs but the intensity is much lower? What if the tasks are much simpler? In this case, I do not need a hardcore microprocessor. Now, this is where a microcontroller comes into place. A microcontroller can be used to execute programs where the task is simple, fixed, and predefined. Space is also an issue here. In a microprocessor system, the CPU is integrated into the chip, but the memory, the input-output ports are all separately connected. But in a microcontroller system, the CPU, memory, I/O ports are all integrated into the same IC, making a microcontroller system much smaller. And that is why we say that a microcontroller is an IC dedicated to perform much simpler tasks. A microcontroller is the integration of a processor, memory, and I/O ports into the same IC. Starting from air conditioners to microwave ovens to traffic lights, everywhere we use a microcontroller instead of a microprocessor. Students, here is a list of microcontrollers, some of which were used in the past, some of which were still being used now. For example, we have the TMS 1000, we have the very famous Intel 8051, then we have the more modern ones, the Freescale MCU and the Renesas RL, etc. Students, let us now discuss the differences between a microprocessor and a microcontroller. Now, first, a microprocessor is used where intensive processing is required, whereas a microcontroller is used where the tasks are much more simpler, where the task is fixed and predefined. Now, in case of a microprocessor, only CPU is integrated into the chip. The memory, the input-output ports are all connected externally. But in case of a microcontroller, the CPU, the memory, and the input-output ports, all of the components are connected on the same single IC. Again, in case of a microprocessor, the clock speed is much higher than the microcontroller. Now, a clock speed basically refers to the rate of execution of instructions. The higher the clock speed, the greater is the rate of data being processed. Furthermore, memory usage is also higher in a microprocessor. Again, the program for the microprocessor can be changed for different applications, but the program for the microcontroller is fixed once it is designed. That is because as the tasks are fixed and predefined, the related programs are also fixed. Both the cost and power consumption of a microprocessor is much higher than that of a microcontroller. Furthermore, the overall size of a microprocessor system is greater than that of a microcontroller system. Now lastly, in a personal computer we would be using a microprocessor, whereas in applications such as washing machines, camera, etc., we would opt for a microcontroller. So students, before we end this video, I have one small question for you. Now, we know that your computer uses a microprocessor, right? But what about your keyboard? Does it require a microprocessor or does it require a microcontroller? You can pause this video to think about your answer. Now, if your answer is a microcontroller, then you are absolutely correct. A keyboard requires a microcontroller to execute some programs which help the keyboard to identify which keys are being pressed. students, I hope all of you have got the correct answer. Well, students, that is all for today. Again, I will see you in the next video. Until then, stay safe.